Chapter 6 Sequential Logic Design Principle. At the first half of this course, before midterm examination, we have already learned about conventional logic circuit, the circuit that its output depends on only its current input. Namely, for example, for some conventional circuit, maybe have got 2 or 3 input and maybe 2-bit output. For example, if input is 0, 1, 1, output may be 1, 0. And if apply input 1, 1, 1, output may be 0, 1. And when apply input 0, 1, 1 again, output will be 1, 0. Okay? Namely, if you apply the same value of input, the conventional circuit will give the same output. Okay? This kind of circuit is conventional circuit. Okay. By the way, what about sequential logic circuit? Its output depends not only on its current input but also the past sequence of input. For example, if you apply input with 0, 1, 1, output may be 1, 0. And when you apply the value of 1, 1, 1, output may be 0, 1. When you apply 0, 1, 1 again, now output may be 1, 1. Okay? Same input value, but the output may be different value. This kind of circuit is not conventional, but it's sequential circuit. Okay, one more example. Maybe if you know and maybe used to use remote control of television. If you press number 1, for example, maybe your television maybe show channel 1, and when you press 2, maybe change to channel 2. When you press 1 again, it's back to channel 1. Okay, this behavior is something like conventional circuit. The output depends on the input, okay, value. But what about this? Okay, remote control also have this kind of channel up and down. For example, if the current channel is channel 1, when you press up, we change to channel 2. When you press up again, we change to channel 3. Note, you apply the same input, right? But the output not the same. And if I press from channel 3, if I press up, up, down, down, up, down, down, up, up, down, down, and up again. How about the channel of television? Okay. You can determine if you know the sequence of the input, right? Up, up, down, down, maybe change to 4, 5, down, down, then 4, 3, up, then 4, down, 3, 2, 3, 4, 3, 2, up, and then 3, right? So you can determine the value. You must know the sequence of the input. So this kind of circuit is called sequential. Sequential circuit. For this kind of circuit, okay, you must know the sequence of the input from the past. But in practical, it's quite impossible that you can memorize, okay, all value of the sequence from the beginning when you use your remote control, right? So actually, you need not to memorize, okay, all past sequence input. But if you know, for example, in this case, if you know that the current status or current state of the circuit, for example, if you know that now the TV signal is signal 2, so now you know that the current state or present state, current or present state, that means you need to know you need not to know that the all past of the circuit. You just know current state. And then if you know the input, so you can predict, okay, or can determine the next state and output. Okay? For example, if I apply input up, so you know that if it's change to channel 3, okay, for example. So for sequential logic circuit, we have one more word that you should know, okay, and understand is state, okay, state. Okay, how to implement for combinatorial circuit? Of course, you just use some logic gate, right? Connect together without any feedback. But for sequential circuit, okay, you also use logic gate, but some part of the circuit will have feedback connection. Feedback mean, for example, output, right? Maybe connect to something, okay? This is feed forward only. But if you have some feedback, this output will be the input of the previous logic gate, okay, for example. Okay, and before go to the detail, let I show you some example about this. Okay. For feedback system, for the simple one, maybe this one. AND gate, right? And if I feedback this one to this one, let's say this is input I and output Q, and the second circuit, this one, change to NAND gate. Okay, input I and output Q. Okay, the first one, okay, this circuit. Okay, if I want to know the output value, again, because of digital circuit, so every variable, okay, can have only two value, 1 or 0, right? So if I analyze this circuit, so I will consider when input I is 1 and when input I is 0, okay? In the case when I is, okay, at first 0, how about the output Q? How about the output Q? output Q will be what? Q, okay, will be what? 0 and anything is 0, right? Q will be 0. Okay, to make difference between Q and the new value of Q after time pass, like I add star, okay, Q star, okay, the next value of Q after time pass. Okay, now, okay, that means now if you apply 0 at here, okay, output will be 0, okay, constant 0. But how about when you apply input I is 1? How the value of Q star or the new or the next value of Q? Okay, when I is 1 and Q is what? It's Q, right? That means if the current value of Q is 0, so it's still be 0. But if it's 1, so it's still be 1. Okay, so you can write it as Q star is Q, same value, okay, of the previous one. Okay, how about this one? For this one, when I is 0, Q star is what? When I is 0, 0 and anything is 0 and then invert, so it's become 1, right? So output Q star is 1. And when I is 1, how about Q star? When I is 1 and Q is Q and then invert is Q prime, right? So output is Q prime, okay, not Q, okay, invert of Q. So this is the result. So note that in this case, the value of Q, okay, can be 0 or 1, right, based on the previous value of Q. Okay. And for this one, the output or Q star, okay, the next value of Q also depend on the previous value of Q, but it is opposite. Okay, if the previous is 1, Q star is 0, right? Invert of 1 is, that means the output may be something like 1. When time pass, it change to 0. Okay, when it's 0, when time pass again, it change to 1, right? Something like this, 1 0 1, and so on. Okay, and some word that you should know about this. Okay, is okay, let us start from this one. Okay, when you apply some input into the circuit and it make the output to be 1, in this case it's called set. Okay, this action or this command, okay, let's call set. Okay, set is the action that make or force the output to be 1. Okay, not depend on the previous value of Q or the current value of Q. Whenever you apply input I, in this case, okay, I 0 into this circuit, the output will be 1. So it's set. So now you know the word set. Okay, set. And oppositely, if you apply some input into the circuit and force the output to be 0, it's called reset. Okay, in this case, in this circuit where you apply 0, okay, it's reset. Okay, make the output Q to be 0. Okay, and the next word, maybe this one. When you apply some input and the output, Okay, should be the same, not change. Is hold. Okay, hold. Okay, output not change. Still be the same value of the previous one. And if the output is opposite to the previous one, for example, in this case, if the previous value is 1, input then becomes 0, right? And if the previous value is 0, then when input is into 1. Okay, in this case, it's called toggle. Toggle. Okay, these are the basic, okay, action, okay, or operation of the circuit that they should know. Set, reset, hold, and toggle. And more what that you should know the meaning about maybe something like electronic okay, circuit is about the stability of the signal. The first one, let's consider this case. This case or this case. For this case, for example, I'll put Q. Okay, I'll put Q in here when I write something like timing diagram. When I apply input to be 0, okay, now output Q will be 1, right? High level. Okay, something disturb and make it to be 0, but if the input still be 0, so output will be back to 1, right? That means it cannot stable at 0 level. It can stable only one level. In this case is high. Okay, high. Okay, can stable only one state. In this case, it's called monostable. Monostable. Okay, monostable. In this case, monostable at high level. Okay, at high level. And the second one in this case, okay, this case also is monostable, but it's stable only low level. That mean value of Q is low. It's low. If something disturb, okay, and make it too high, it cannot stable at high. It will back to low. Okay. This one also monostable. Okay. Can stable only one state. In this case, it's stable at low level. For the previous example, this one is higher level. Right? Cannot stable at low, but can stable only high. Okay, it is monostable also. At high only or at low level only. And how about this one? In hold mode. In hold mode, Q star is Q. That mean I write it here. That I space. Okay, in this case, draw some diagram. Okay. The field of Q. If the previous value of Q is low, so it's continue to be low, right? That means at this point of time, the value of Q is the same value of the previous value of Q. Okay, it's the same. That means if the previous is high, so it can stable at high level. And if the previous value is low, when time change is still below, right? So that means it can stable at low level also. Okay, in this case, it's called bistable. Namely, it can stable both state, high also and low level also. Bistable. And the last one, in this case, Q star is Q prime. If I write timing diagram of Q, maybe you can write something like this. If the previous value is high, okay, then when you invert it change to low. When it become low, when you invert it change to high. So it cannot stable at high and cannot stable at low because it changes state, okay, every time. So in this case, it's called unstable. Unstable. Okay, unstable. For stable, you have two kinds, okay? Monostable and bistable. And if it's not stable, it's called unstable. So for bistable circuit, you can use it as memory, right? Because if you know the current value, for example, this point of time, if you know that, now the circuit is bistable. If you know the current or the present value is low or zero, that means you know that the previous one also zero. Okay, the previous also zero. Okay, or if you know that this point of time is 1 and you know now the circuit is bistable, that means you know that the previous point of time, the value of Q also 1. Okay, that means the circuit have memory, right? Have got memory, okay? Can memorize, okay, the value from the past and keep the value to the present, okay, of time. Okay, so this is some basic, okay, technical term that you should know and understand. Okay, let's back to the slide. Okay, for sequential logic design, actually that there are many kind. Okay, for example, feedback sequential circuit and clock synchronous. Okay, state machine. For feedback sequential circuit, the state will change. Okay, when input change. Okay, when input change, the output will change suddenly. Okay, for example, maybe you know this name later. Okay, maybe something like latch or flip-flop. Okay, it have bistable state. It can stable both high or low. Okay, both high and low level. And the next kind of sequential logic, okay, that you design in this class, okay, is clock synchronous state machine. Machine is the circuit that operate with some step, right? There's some step, there's some mechanism, okay, to operate or doing something with have got the state. And this circuit will change the state, okay, synchronized with clock. What is clock? Okay, clock, tick tock, right? Okay. Clock is the signal, okay, that used, okay, to determine the timing of state change. Namely, when clock tick, okay, the state will change. When clock tick, when clock tick, the circuit will change state. For the detail, you learn later, okay. And again, like the previous one, some signal have active high and active low. Clock also. If okay, clock is something like this. Clock may be something like this signal, high low, okay, high low, okay. And for when clock change the value from low to high, okay. This one is called positive edge, okay, positive edge ticker. If it change from high to low, okay, it's negative edge. If the state machine or the circuit change state at positive edge, it's called active high. If it change at negative edge, it's called active low. Okay, this is for flip-flop. Okay, flip-flop will change the value at the edge of the clock. Okay. But for some element like latch, it will change at logic high level or logic low level. Okay, in this case, okay, if it change at logic high, it's called active high, or change at low level of clock is active low. And one more technical term that you should know is period. Okay. Period is very easy for you, right? Namely, when it change, okay, before repeat the same pattern. Okay, it is a period of time. Frequency, okay, is 1 over period, right? And this duty cycle or duty ratio. For duty cycle is the duration, okay, of active level indicates high, okay, compared with 1 period, okay. The ratio between active level, okay, high to 1 period is called duty cycle or duty ratio. Okay, now let's consider this circuit. This is inverter. This one also inverter. Okay, and if you connect, okay, this output to input of this inverter and output of lower inverter to input of upper inverter. Okay, what happened? Okay, now let's naming the signal name. Name this output of the upper inverter with Q, and the lower one is Qn. Qn. If you consider this one system, this system have output Q and Qn. There is no external input. Okay, no external input. So now let's consider and analyze, okay, this circuit. How about the result? Okay, at first, each inverter, okay, has a characteristic curve, relation between output an input with this one. Namely, if you apply, for example, 0 volt input, output will be maybe 5 volt. Okay, for example, if you apply 0.5, output also 5 volt. If you apply input with 4 volt, output, okay, maybe 0 volt. If you apply 5, output also 0 volt. So if you apply low level, output will be high. If you apply high, output will be 0. So it's invert, right? Okay. For this one also, okay, this is inverter also. So now let's consider what happened. Let's start with, for example, 3 volt at here. 3 volt at here. Maybe this point, around this point. Okay, 3 volt. This point. That means output will be what? Maybe, for example, around 5 at here. For example, 0.5 volt. So now output is 0.5. Okay, and V into now also 0.5. That means at this point V into now is 0.5. Then output here, this one, the second one is 5 volt, right? So now output this one is 5. Okay, when output is 5, then update this from 3 to 5. That means now change to this one, right? 5. So output then now become 0, right? This level also is 0. So now output then change to 0 volt, then update the one to 0 volt. So this one is 0, and then output become 5. When 5 at here, so 0 at here, 0 at here, 5 here. Now it's nothing, right? It's stable at this state. Namely, Q is 0, Qn is 5. It's stable. Okay, stable. Namely, the operating point for this one is maybe this point. Okay, and for this one, maybe this point. Okay, stable at here. Or if I combine this one and this one, okay, into the same one, namely this V out 1 and V into it is the same, right? The same. V out 1 and V into, okay. This axis and this axis is the same one. Okay, so we can draw this curve to this one. And for the previous example, V out 1 is 0, right? And V out 2 is 5. Okay, stable state. So V out 1 is 0. V out 2 is 5. So it's stable at here. Okay. Namely, Q is logic low. Qn is logic high. Okay, at this point. And if I start the consider if I start this one with for example 2 volt, what happened? If start at 2 volt, V in 1 is 2, V in 1 is 2, be around here, 4. Output maybe for example 4 point something, 4.5, okay, for example. So this output is 4.5 volt. We out, one is 4.5, then V into also 4.5, 4.5. So the output may be 0. Your 2 then become 0. That means this update to 0, right? Same signal. So now it's going to 0 at here, this point. So VR1 now become 5. V into also 5, right? So V into now change to 5. And output of VR2 is 0. And now it's 0 at here, 5 at here, okay? Become stable, okay? Not change. So if you start at this point, okay, at this point, okay. After time pass, okay, it move to stable at this point. Namely, Q become high. Okay, Qn become low. Okay, or logic 1 and 0. Okay. So this circuit is bistable. It's bistable element because it can stable with two state. The first one is Q is 0, Qn is 1. Okay, and Q is 1 and Qn is 0. Okay, note. Okay, Qn normally is opposite value. Okay, so it's named with n maybe negative. Okay, or negate. So this kind of circuit is called bistable element. Okay. Anyway, actually, this circuit can stable or can balance at this value also. If I apply 2.5, okay, if it is this point is 2.5 at this middle, right? Output also 2.5 volt, 2.5. That means it's 2.5. Middle also 2.5. So what happened? 2.5. Okay, it's stable, right? Okay, can be steady at here, right? 2.5. In this curve is this point. This point is called metastable. Metastable. It is by itself at 2.5. Actually, it's not logic low, right? And it's not logic high. Okay, not low, not high. So it's inferior. Okay, in logical level. Okay. If the circuit, okay, become metastable, what happened? Yes, okay, it can keep, okay, this level until some noise, okay, some electrical noise is coming, some noise or disturb, okay, the voltage at this point or this point. For example, if it disturb, for example, this is Q, right? It's time. If now 5 at here, 0 at here, 2.5 maybe at here. If it then now if your system, okay, become metastable, okay, steady at 2.5. If some noise disturb, so some noise, okay, the noise maybe make this voltage level higher or make is lower. Okay. If it make this point higher, namely maybe from 2.5 to a little bit to 2.6, so we move, okay, to steady at this point. At this point, move still at this point. But if the noise, okay, disturb and make this voltage level become lower, so it will move to stable at this point. So if the circuit become metastable by itself, it's not high, it's not logic low, okay, no meaning, okay, invalid. Okay, and when noise coming, which you don't know when noise come, right? You might wait maybe some microsecond or some millisecond, okay, when noise coming and disturb. Okay, you don't know when it's coming, and when it's come, you don't know also that you disturb the voltage level become higher or lower. If it make it higher, okay, you go to this state, okay, Q is 0. But if it disturb, it level change lower, so the new stable state will be this point, okay, Q is 1. So so when the circuit change to metastable, you cannot predict, right, the next value of Q. Okay? It's based on the noise, right? That will coming, that will disturb the signal become higher or lower level. So in this case, it is called unpredictable. Unpredictable. It's something like for metastable. I compare with in mechanical beam. It's maybe ground level. It's ground level. And beam. This one. If this side touch this ground is low, right, and this is high, okay. And one more, maybe this one. Okay. For the second stable state, low at here and high at here. Maybe we consider this side is Q, this one is Qn, something like that. Q is high, Qn is low, Q is low, Qn is high. Okay, for example, at metastable, okay, like this like this one, okay. This one, okay. Qn, okay. Same level, but if some noise, okay, disturb, okay, some vibration, for example, mechanical vibration, if the vibration make this side of beam, okay, change to the lower level, so what happened? We go to stable at this state, right? But if the noise disturb, make this side lower and this side become higher, so the beam will go to stable at this state, right? This one also, okay. And you cannot know, right, when the vibration or the noise will come in, and you don't know the vibration will make this side or this side become higher or lower, so it's unpredictable. Okay, and let's consider this circuit in digital view. Right now, I consider this one in analog style. Now let's analyze in digital style. Okay, at first, let's consider this one and this one, okay, separately. Namely, again, this one is I write is Q, right? After time pass is Q star, the new value of Q after time pass. Of course, because input is from Qn, right? So Q star is Qn prime. This one also, the second one, the reverse inverter. Get the input from Q with invert. Okay, the new value of Qn, I write Qn star. Qn star is invert of Q. So because of digital signal, so each, okay, each variable, okay, can have two values, 0 or 1. Okay, so I write all possibility value of Q. Okay, the current state may be 0, 0, 0, 1, 1, 0, and 1, 1. Okay, all possible value of Q. And now, how about the next state or the next value of Q? Okay, based on this one. Q star is Qn prime. Qn is 0, 1, 0, 1. So Qn star is 1, 0, 1, 0. How about Qn star? Qn star is Q prime. Q is 0, 0, 1, 1. So Qn star is 1, 1, 0, 0. Okay, infer. So now we've got this one. Then I write the state of the circuit. There are 4 states. So our state 0, 0 and circle around it. 0, 1, 1, 0, and 1, 1. Okay, now let's consider if the circuit is at 0, 0 state. When time passed, the time change, okay, the state will go to 1, 1. 0, 0 change to 1, 1. And if the current state is 0, 1, when time passes, it will go to 0, 1. 0, 1 to 0, 1. Then it can steady it here, right? Can stable it here. And if the current state is 1, 0, so it's go to 1, 0. Okay, go to itself after time passed. And 1, 1 go to 0, 0. So we know that for this one, the state of 0, 1 is stable because when time change or time pass, its value not change. This one also stable, right? When time pass, okay, the value not change. Okay, so there are 2 stable states. This one not stable because it cannot keep at 0, so it will change to 1, 1, and it cannot keep at 1, 1 state. Okay, because it's 1, 1 when time passes go to 0, 0. So this circuit have got 2 stable states, so it's bistable. Okay. For more detail about this 0, 0 to 1, 1 or 1, 1 to 0, 0, if you consider 0, 0 to 1, 1 first, this 2-bit, if you consider this 0 is 0 fold, 1 is 5 fold, what happened? This one also 0 fold to 5 fold, If this bit change at the same rate, 0 to 5, this one, okay, same rate of these 2 bits. That means it meet at 2.5, right? 2.5 at the same time. So what happened? Yes, it become metastable. So when become metastable, after that you cannot predict, right, the next value of Q. See, it's become unpredictable. Okay, because you don't know how long that we will stay at metastable. Okay, based on the noise that come. Okay, based on the coming noise, and you don't know that the coming noise will make the voltage level change higher all over. Okay, now if this bit and this bit, okay, change with different rate. For example, if this bit change faster, what happened? 0, 0, this bit change to 1 before this bit. That means this bit still be 0. So it's go to 1, 0, right? When it's go to 1, 0, can it go to 1, 1? No, because it's stable at 1, 0, right? Okay. If the current state is 1, 0, okay, when time pass, it's go to 1, 0. Okay. And what happened if this bit change faster, change to 1, okay, before this bit? That means this bit still be logic 0. So it's go to 0, 1, right? Go to 0, 1. Again, if it change to 0, 1, so it's stable at 0, 1. Okay, it's not go to 1, 1 state. Okay, and for 1, 1 change to 0, 0 also. Okay, if the bit and this bit, okay, change to 0, 0 at the same speed from 5 volt, 5 volt to 0, 0 volt. So it meet at metastable and become unpredictable. And if this bit change faster, change to 0 before this bit, so it's become 0, 1 and steady at here. And if this bit change faster, becomes 0 before this bit, so it's go to 1, 0. So in general, if your circuit, okay, is 0, 0 or 1, 1, the circuit will be unpredictable because you don't know, right, that you go to metastable or not, and you don't know that you go to 0, 1 or 1, 0. Okay, so it's unpredictable in this case. Okay, this is some basic, okay, knowledge that you should know. Namely, at bistable element, at bistable, it will stable at the state that value of Q, Qn are not the same, okay, different value. Namely, we stable at 0, 1 or 1, 0. If Q, Qn are the same value, 0, 0 or 1, 1, okay, the circuit will be unpredictable because you cannot predict the next value of Q. So you should avoid this condition, okay, when the circuit become bistable. Okay, and this page that show, okay, some basic element or device that you will study. Latch, flip-flop. Latch is the device that we will change, okay, output, when input change. But for flip-flop, the value will change with clock. Okay, need clock to make the timing of the change. And this just some list, okay, of the device that you will study about SR latch, D latch, D flip flop, SR master slave, SR flip flop, master slave, JK flip flop, something like this. Okay, now let's consider this circuit. This circuit, there are NOR gate, or actually you can consider it as OR gate with invert at the output, okay, namely active flow output. And this circuit have two external input from R and S. Okay, if you consider the system at this one, output also QN, input R and S. Okay. Again, because this is digital circuit, so value of R and S can have only 0 or 1, right? So it can be 0, 0, 0, 1, 1, 0, and 1, 1. Okay, and 1, 1. So let's consider. Again, we analyze by consider this one and this one. Q star is the new value, or the next value of Q after time pass. Qn star also. Okay, let's consider when Rs, okay, is 0, 0. What happened? What happened? Okay, when R is 0, 0, okay, this is 0. This one is Qn. 0 or Qn is Qn, and when invert is Qn prime, right? So Q star is Qn prime. This one when S is 0, it is form Q. Okay? Q or S and invert. Then it become Q prime. So Qn star is Q prime. Based on this relation, we know that this one and this one is same as the previous one, right? Same as this circuit, right? Q star is Qn prime, Qn star is Q prime. Yes, it's bistable. That means if you apply input SR with 0, 0, the circuit now have the same behavior of this one. Namely, if you apply 0 at here, this device, okay, the same as inverter. Okay, this one also when S is 0, okay, and the result of operation is same as inverter. So if you apply 0, 0 at here, okay, 0, 0 at here, the circuit you operate same with this one. This one. Okay, so it's QN. It's bistable circuit. So when you analyze, you get the same result. And how about if S is 1, R is 0? When S is 1, 1 is 1, okay? 1 or anything is 1, right? When invert, it becomes 0 at here, okay? And for R is 0, R is 0. 0 or Qn is Qn when invert is Qn prime. So in this case, again, there are 4 cases of QN, right? 0, 0, 1, 1, 0, and 1, 1. Okay. Q star is Qn prime. Q star is Qn prime. Qn is 0, 1, 0, 1. So it's 1, 0, 1, 0. Qn star is 0, right? So 0, 0, 0, 0. So from this, when you analyze, you get the result like this. If the current state is 0, 0, when time passes, it go to 1, 0. 0, go to 1, 0. If the current state is 0, 1, it go to 0, 0. 0, 1, 2, 0, 0. from 1 0 to 1 0. Okay, stable at here, right? 1 1 go to 0 0 again. Okay, if this bit change faster, let's go to this one. If this bit change faster, go to this one. Anyway, the current state, every state after 10 pass, if you go to 1 0, okay, change to this one. When time change, is go to this one. When time pass, go to this state and stable at here. So you can start from any state, okay, but finally it will go to this 1 0 state. So this one is monostable, right? Monostable. Okay, have only one state. Okay, that it can be stable. How about this one? S is 0, R is 1. Okay, it's similar, right? S is 0, R is 1. R is 1, S is 0. So R is 1, this output then become 0, right? Q star is 0. And Qn star is what? 0 is Q prime. So in this case, okay, you can analyze this one. Okay, Q is 0. Qn star input of Q. Okay, 0 1 1 1 1 0 0. And when you write the diagram, again, if you start from 0 0, it's go to 0 1. If you start from 0 1, go to 0 1. If you start from 1 0 state, it go to 0 0. And the current state is 1 1. Okay, next state will be 0 0. Again, if these two bits change different speed, you go to 0 1 or 1 0. Okay. Anyway, any state that you start, okay, finally is you go to 0 1 state. This one also monostable. And the last one, when S is 1, R is 1. S is 1, R is 1. 1, 1. Output is what? Is 0, right? 0, 0. Okay, so it's constant 0. That means every state, okay, you go to 0, 0 and stable at here. This one also monostable. But uh, in practical, okay, we rarely to use this one, because if uh, you apply S R is 1 1, we force the output become 0 0, right? And after that, if we change value of SR to 0 0 at the same time, what happened? For SR11, change to 0 0. So now it's become bistable. For bistable, if the current state is 0 0, what happened? It's become unpredictable, right? So not so good. Okay. So normally we avoid this condition. And how about this one? When S is 1, R is 0. Stable at here. Q is 1, Qn is 0. That means when you apply S is 1, R is 0. Okay, we force output Q, okay, become 1, and Qn is opposite to Q, is 0. Okay, this is called set. Okay, it's called set. Okay, and when you apply S is 0, R is 1. S 0, R is 1, it's stable at 0 1. Q is 0, right? Qn is opposite to Q is 1. Okay, let's focus this one. So when you apply 1 0 1 0, okay, R is 1, S is 0, it forces output Q to be 0, so it's called reset. Namely, actually S is from set. When set active, when S input is active only, you force output Q to be 1. When input R active only, you force output Q to be 0. If SR is not active, the circuit will be bistable. And if the current state is 1 0 or 0 1, it will be stable, okay, not change. So actually it is hold mode, right? Hold. When SR is not active mode, okay, the value of Q will not change. Under the condition that QN is very important, will be stable when QN is 1 0 or 0 1, okay, it's different. If the current state is 0 0 or 1 1 and your circuit become bistable, the output of the circuit will be unpredictable. Okay, will be unpredictable. So be careful. Okay, and when S is 1, R is 1, okay, it force output Q can become 0 so in this case. Okay, that's summarized. Okay, this kind of device is called set reset latch or SR latch. Okay. For the function table, write something like this. When SR is 0, so not active board, okay, Q, value of Q will be last Q. Last means the previous, right? Last previous value of Q. If the last value is Q is 0, so the current value of Q is also 0. And when SR is 0, 1, R active early, it forces output Q to be 0. When S is 1, S active early, R is 0. Output Q forced to be 1. When SR is 1, 1, QN now is 0, 0. Okay, for the symbol, now we will write something like this. It's SRQ, this one is QN. You can write this one or this style. Okay, it's active flow output of Q, opposite Q, or Q bar. Okay, you can write in this style or this style or this one. Okay, please choose one of these. Okay, not mix this one or have one this one. Okay, and okay, for this it shows some example of timing diagram to show the operation of SR latch. Okay, let's consider if I start Q from 0, SR is 0, 0. At this point of time, Q is 0 and QN is 1. Okay, now S is 0, R is 0, right? 0, 0 both. When time passes, then from this point to this point, for example, this point also 0, right? 0, right? S R is 0, so not active both. So output Q still be the same. Okay, it is in hold mode. Okay, it's hold mode. Value of Q not change. That means this point of time, value of Q same as the previous point of time. So the previous point of time Q is 0, so this point of time Q also 0. And what happened when it changed to 1 at here? Change 0 to 1 at here, and R still be 0. So now input is 1 0. S set actively. Okay, it forces output Q change to 1. After that, when input is 0 0, so this point of time is in hold mode now. It's same as the previous one. Now previous one is 1. And when input R change to 1, S is 0. R active only. Okay? R is active only. So it's reset, right? It's make Q to be 0. Okay, force Q to be 0. And this point of time is 0, 0, not active both. Okay, same value of the previous one. Okay, 0 at here and 0 at here also. And now S is 1, R is 0. What happened? What happened? Set, right? Set. Okay, S actively. So Q change to 1. And 0, 0 at here not change. Okay, the previous is 1, so now is 1 also. Note, until now, I consider the value of Q, right? For Qn, here is opposite to Q. Okay, and when now is S is 0, R is 1, reset. Okay, Q forced to be 0. At this point, S is 1, R is 1. Okay, 1, 1. Now Qn is same value of 0, 0. And 0 at here, 1 at here. What happened? Reset, right? Q is 0. Q in opposite to Q is 1. And 0, 0 at here. Okay, same value as the previous one, 0. So now it's 0 also. And when S is 1 at here, it's set, right? R is 0. Make Q to be 1 at here. And 1, 1 at here. Again, force Qn to be 0, 0 at here. And 1, 0 at here. Set, right? Actively make Q to be 1. And Qn opposite to Q. And 0, 0 at here. Nothing changed. The previous value is 1, so now it's 1 also. And 0, 1, reset. Okay, Q is 0. And 1, 1 at here. What happened? Qn is 0, 0. And what happened if now SR, okay, change to what? Change to 1, 1, right? Now 1, 1, Qn is 0, 0. And when you change S and R to 0, 0 at the same time, what happened? Okay, now when your circuit become bistable, right? By applying 0, 0 at input SR, right? And the current state now is 0, 0. So it's unpredictable. Namely it maybe go to what? 1, 0 state or 0, 1 state, or go to metastable. If it become metastable, when noise is coming, it may disturb. This become high, this one become low, or disturb, this become low, and this one become high. Okay, and you don't know why, but when noise coming, maybe come fast or come late. Okay, already come or late coming, you don't know. So when you write in time unit again, it shows something like this. Okay. So this one is just show as unpredictable. Unpredictable. Okay. Unpredictable. So you need to know, okay, the value of the output until you apply some input that force. For example, for the output. For example, if I apply 1 at here and 0 at here, okay, now it force the output become 1 at here and Qn is 0 at here. Okay, so it is back to a predictable value. Okay, okay. This is for example, and some timing parameter that you should know about Latch. The first one is propagation delay. Propagation delay, and propagation delay is the time that take for the transition on the input signal to produce a transition on the output signal. It's something like maybe this one is the circuit some system, and when input change, right, and wait with propagation delay, you can observe the change at the output. Okay? It's like the traveling time, okay, where from the input terminal to the output terminal, okay, like traveling time. Okay? You can observe by the change, okay, of the input value and output value. For example, this input change make output Q change. So it takes time, right? It takes time with this propagation delay. And for notation, we write this one SQ. Okay, change of S. Okay, cause Q change from low to high. And this one, change of input R. Okay, cause Q change from high to low. Okay, for example. And one more parameter is this one, minimal power width. Minimal power width, what is it? Okay, let's consider if you want, for example, want to change the input. For example, now if you want to change Q from low to high, for example, so you give the input S to 1, right? You must apply S, okay, of logic 1 long enough, okay, at least minimal power width, to make sure that Q will change to 1. If you apply this input S, for example, very short, so what happened? It is very short. Namely, we apply when we change it to 1 and then back to 0. Suddenly, what happened? Q, first of all, it is 0 volt, right? When go to 0.1 and it's back to 0, suddenly what happened? So it's back to 0 again, right? So the output will be not change. That means if you apply this input very, very short, so it cannot make output change. If you want output change, you must apply at least with minimal power width parameter. Okay. And one more problem that may occur if you apply input S, for example, less than minimal power width, but not so much. Namely, maybe around right here, the value of Q may be changed. If it changed to around 2.5 volt, what happened? What happened? If your is back to 0, when output Q, okay, try to go up from 0 to 5, but it is not reach to 5. Your input is back to 0. Okay, it become bistable, right? Now I is 0. So if Q is 2.5 exactly, so the circuit will become metastable, right? Metastable. So After that, it will be unpredictable. Or if it's not 2.5 exactly, but you don't know, right? It is less than 2.5 or greater than 2.5 volt. So it's unpredictable. So in general, if your input apply less than minimum power width, the output will be unpredictable. It's something like this beam. This beam. If you press this beam a little bit, and then you remove or release the force suddenly, so it's back to this state, not change, right? If you want to make a change of the speed, you must press this one long enough until this side of beam become higher than this level. So after that, you can remove this force, right? So you can make the state change. But if you force this one and remove when the beam is around at the middle level, after that you remove, so it may be metastable, right? Balance at here, or maybe it's back to the previous state, or maybe change to this state. So it's unpredictable. So be careful when you apply the input. It's much long enough. It's much longer than minimal power width of the latch. Okay, and for this one, it's a thing. This OR gate. For the previous one, it's OR gate with invert at the output, right? Active low at the output, active high at the input. If change to active high at the output and active low at the input, you get a similar result, but opposite value. Namely, this circuit will be bistable when you apply 1 here. 1 here. Maybe one invert, right? Become 0, then all this one. So it becomes Qn prime at here. And for this side, Q 1, then invert becomes 0 at here, or Q prime. Okay, it becomes Q prime at here. So it becomes bistable when S is 1, I is 1. Let's take this one. And if you apply 0 at here, invert become 1, right? And or 1 or anything is 1. So it will be set when apply input S, active low S with 0. So it's stable at 1, 0, Q is 1 when S is 0. And when R is 0, S is 1. So 0 invert is 1 at here. So output is 1 at here. And when invert at here, then becomes 0 at here. So when you apply R to be 0, okay, in this case, you make output Q become 0, okay, stable already state. And when you apply 0, 0, 0, 0, now output active at here is 1 at here, active at here, 1 at here. Output would be 1, 1. So finally, you see that this one acts as its latch, but change just active level of the input. Namely, this guy is active low. Set reset back. Namely, if you apply 1 at here, 0 at here, are active low, right? So it force output Q to be 0. If you apply 0, 1, S active early is set, force Q to be 1. If you apply 1, 1, okay, not active both. So now the circuit become bistable. So it's the value is last Q. Okay, Q is last Q, same as the previous one. Under the condition that the value of QQin must be 1, 0 or 0, 1. Must be not the same. If QQin is the same, what happened? Become unpredictable. Okay. And if active both 0, 0, output in this case is, because output is active high, so it become 1, 1. Okay, that's all. Okay, that's all for today.